Hey everyone, welcome back. Today we are going to be talking about troubleshooting common issues with log ingestion and analysis, right? This module covers the most common troubleshooting scenarios you'll encounter when working with log ingestion systems. Understanding these issues and their solutions is critical for maintaining reliable security monitoring infrastructure. Common log ingestion issues. We have missing or incomplete logs, expected log entries and not appearing in security information event management system, right? It's not showing up. Gaps in log timestamps, certain systems not reporting, agent connectivity issues, incorrect log source configuration, network connectivity problems, log source system overload, where you're overloading your system with too many logs. Verify agent status and connectivity, check network paths and firewall rules, review log sources systems resources, validate configuration files. For the parsing failures, we have raw logs appearing without proper field extraction, meaning those logs weren't actually filtered out and different fields weren't put together. So there might be a field for the time that you logged in and stuff like that, or the time that it happened, right? Timestamps. That might be a field. Timestamps might be a field. Parsing errors in the SIEM dashboard. That is also not good. Incorrect field mapping. Common issues, we have incorrect parsing rules, log format changes from source systems, special characters in log data, time zone mismatches. So to fix log parsing failures, what you would do is you would update the parsing configurations, test parsing rules with sample data, handle special characters properly, and standardize time zone settings so that you can troubleshoot and find the root cause of the parsing issues, right? Then we have performance-related issues, ingestion bottlenecks, slow log processing, delays between log generation and SIEM availability, growing backlog and ingestion queues, system resource exhaustion. So this is when logs aren't coming through and being processed in a timely manner, right? We have resource exhaustion, which is like you're using up all your CPU, right? Insufficient processing capacity, network bandwidth limitations, storage, input-output bottlenecks. Say you have a really slow drive, it's not going to be able to send that data very fast. And the network, even if you have a really good network, that drive is still going to be a bottleneck on the network, meaning the drive isn't fast enough to send it as fast as the network is wanting to send it, right? We have inefficient parsing rules. So you want to scale processing resources, optimize network configurations, like all your config files and stuff. Implement better storage solutions. That's meaning like going with like NVMe, M.2, stuff that's a lot faster, right? Paired with a good network, it would be really fast, right? Sending that data to different things, right? Streamline parsing logic. So having a good baseline for your parsing logic that is efficient, right? Memory and storage issues. For this one, we have system crashes or restarts, disk space warnings, high memory utilization. So why might it be using all that memory? Why might the disk space be giving you warnings? Well, the disk space warnings would be because you're using too much space on your drive, right? You might want to look at your retention policies if that's happening. Or look at, is your log server being overloaded, because it might be sending way too many logs. You might not have like a system that actually picks out these different logs. So there might be authentication to temp logs, and there's a bunch of different logs, right? But picking out the right ones and only doing like the most important ones that you're actually going to need is important, because if you just go through and just do, I want all these logs to be sent, I want every log to be sent, then basically with that, you're just going to be sending way too much stuff. To prevent this, implement log rotation policies, sending it off-site and stuff like that. Or just backing it up somehow. You don't have to back it up to the cloud or anything, but that is an option, right? But a cloud provider could get a cloud provider could be compromised, right? And then all your files are like out there. Because I don't know what cloud providers are trustworthy and stuff like that. But set up automated cleanup processes, monitor resource utilization, plan capacity based on log volume. And basically, with plan capacity based on log volume, you're going to plan, I need this much storage, I need this fast of storage so that I can send it faster and I don't have any delays. Because it's very important that I get this log data and stuff. Because this company's like a Fortune 500 company that needs access to these logs like immediately, stuff like that. And so you're going to want to do like NVMe drive, stuff like that. That's just super fast. And you want to have cold storage that's like maybe a little bit slower. I mean, you don't really got to have those immediately, right? But you could use NVMe for that, but I don't know if you'd want to do that. But just plan the capacity, how much storage you're going to need. Is it going to be like a mix of disk drives and a mix of SSDs and a mix of NVMe drives, fast NVMe drives? Or is it just going to be one select thing? So for data quality problems, this is like log format inconsistencies, like words messing off the thing, right? You got letters off the end of the word that aren't lining up with it, stuff like that. Different like date time formats, say another country goes with this time, but you need to convert it to this time. So you got to think about that whenever like you're in different regions, say like United States and you're going over to like Germany or something, right? They're going to be using a different time system, right? Millisecond precise differences, right? NTP is like an NTP time server, right? Network time protocol. And NIST is like in charge of that, keeping the time with these like really fine-tuned time clocks, stuff like that, to keep your time synchronized and stuff like that across all different time zones and stuff. So they track very precisely down and get like the most accurate time available for those regions and stuff. You know what? It wouldn't hurt to show you guys that website, would it? NIST time. So I mean, you got these time servers, right? But this is NIST website. They should have like a live thing to show you it, but they literally keep track of all like technology based stuff. But see, you come to this website, boom, you get Pacific Daylight Time over here, UTC 7, Mountain UTC time, you get Central Daylight Time, UTC 5, Eastern Daylight Time, and you get all this like time data and stuff, right? And this is what keeps, and it's even telling me my clock is off. What? My clock is off. Well, it's not in the right time zone anyway, so I don't know how my time got switched to Pacific Daylight Time, but it's 0.197 seconds off, so it can account for that. But you can see each region like all across the United States, right? Every U.S. state is on here, right? They got Alaska, Hawaii, like any time is going to be on here, right? Except like overseas time, like Germany, stuff like that. You also get a 24-hour clock, which synchronizes it with 24-hour time, which is pretty cool. Then you have, basically, I just wanted to show you that website in case you ever want to go mess around with it. Field mapping errors, we have data appearing in wrong fields, missing critical information, inconsistent field names. The solutions, we have standardize the field naming conventions, create comprehensive mapping documentation, implement field validation rules, regular mapping review and updates. So for network activity, connectivity issues, agent to server, test network connectivity, ping trace route. So you want to ping the IP address and make sure that you're able to connect and send packets, meaning that they are connected together. Verify firewall rules and port accessibility. Your firewall may be blocking one of your PCs from accessing it, right? Check SSL, secure socket layer TLS, certificate validity. Monitor network latency and packet loss. And you can monitor packet loss with ping, right? Not so sure about traceroute. It probably does do packet loss as well, and network latency and stuff like that. But for common like firewall and security restrictions, you have corporate firewall blocking log traffic, security groups preventing communication, proxy server interference, VPN connectivity issues. These could all be reasons that your log server is not connecting with the agents, right? Then you have work with network security teams, document required ports and protocols, implement proper certificate management, configure proxy settings when needed. Monitoring and detection, we have proactive issue detection, log ingestion rates, processing latency, error rates, system resource utilization, QDEPs, and I'm pretty sure you just have this in like a dashboard or something, showing you the log ingestion rate, stuff like that. If you have a really nice SIEM dashboard or something like that, or just the Splunk dashboard might work. Then you have alerting strategies, set up alerts for ingestion failures, monitor for unusual log volume changes, alert on parsing error increases, track system performance metrics. And these are some of the strategies. But for the health check implementation, right, we have automated connectivity test, regular parsing validation, performance baseline monitoring, capacity planning alerts. For documentation best practices, we have troubleshooting methodology, identify the problem, isolate the issue, analyze root cause, implement solution, verify resolution, document findings, update runbooks and procedures, test and monitor result, apply fix with minimal impact, use logs and monitoring data, determine scope of effective systems, gather symptoms and error messages. So this is like the troubleshooting methodology, right? Maintain troubleshooting runbooks, document known issues and solutions, keep configuration change logs, create escalation procedures. Real world, we have mass agent failure, multiple agents stop reporting simultaneously, investigation, network change caused connectivity loss, solution, updated firewall rules, restored agent communication. Scenario 2, parsing performance degradation. Problem, log processing became extremely slow. Investigation, new log source introduced complex parsing rules. Optimized parsing logic, added dedicated processing resources. For scenario 3, data quality issues. Problem, critical security events not being detected. Investigation, log format change broke field extraction. Updated parsing rules implemented format validation. For troubleshooting tools, for like Linux command line stuff, we have tel, grep, awk for log analysis, netstat, SSS for SSS can verify connections and stuff like that. For network connectivity, top and htop for system resource monitoring like CPU, RAM, stuff like that. For platform specific debugging tools, that's just any other debugging tool that you could use on Linux, stuff like that. SIEM specific tools, built-in diagnostic dashboards, query tools for log analysis, configuration validation utilities, performance monitoring interfaces. You also have packet capture, Wireshark, TCP dump, network monitoring platforms, connectivity testing utilities, bandwidth measurement tools, avoiding common issues, regular system maintenance, capacity planning and monitoring, configuration management, regular testing of backup procedures, test configuration changes in development, document all modifications, implement rollback procedures for change management processes, monitor systems after changes, right? For training and knowledge transfer, we have train team members on common issues, maintain up-to-date documentation, establish troubleshooting procedures, regular knowledge sharing sessions. Remember, document everything. Most troubleshooting issues are repetitive. Good documentation saves hours of investigation time. Pattern recognition improves with experience. Systematic approaches yield better results. Prevention is always way better than reactive troubleshooting. For the critical success of troubleshooting, maintain comprehensive monitoring, implement proactive alerting, keep detailed configuration documentation, establish clear escalation procedures, regularly review and improve your processes. Thank you all for watching. I hope you learned something from this video about troubleshooting. In the next video, this will probably be our last video on log ingestion, besides maybe a lab, right? But thank you everybody for watching. Bye.